Hey guys, all right, in this video we're going to be looking at some exothermic, endothermic questions with some energy diagrams involved with it. We got some multiple choice and short answer. So this first one, which of the following best helps explain why the value of delta H for the dissolving of CaF2 in water is positive? Okay, without looking at the answer choices, just talking about what's going on. CaF2, we should be able to realize that that's a salt. That's an ionic solid. Calcium being the metal and fluorine being the nonmetal. And when it's in water, it's going to dissolve, okay? When it's saying that delta H is positive, okay, that means it's an endothermic reaction. That means that energy needs to be going into the system in order to make the salt break apart. So we're trying to figure out why dissolving a salt would give a positive delta H, what that would be a good answer choice for. So the first one, CaF2 is insoluble in water. That's just not even a true statement. CaF2 is soluble in water. All salts are soluble in water. CaF2 solid dissolves in water to form CaF2 aqueous particles. That is a true statement. That's the opposite of A. But this doesn't give us a reason or reasoning why delta H should be positive, okay? We'll talk about that with the next two answer choices. Ca2 plus ions have very strong ion-ion interactions with fluorine ions in the crystal lattice, okay? And part D says calcium 2 plus ions have very strong ion dipole interactions with water molecules in the solution. And these two I want to combine in figuring out what is the right answer, because we want to know why it's a positive endothermic reaction, okay, that's going on between the two. Now, when calcium and fluorine combine, that's an ionic bond, right? So C is talking about a strong ionic bond. And part D is talking about a strong ion dipole interaction, which is an intermolecular force. Okay. Generally speaking, ionic bonds are always going to be stronger than intermolecular forces. So it is going to take more energy to break an ionic bond than the amount of energy that it would take to break an intermolecular force. And in this particular instance, energy goes into the ionic bond, and intermolecular force, when that ion dipole interaction combines, it releases energy. And for it to be positive, the ionic bond must be stronger, and therefore these ions have such a strong interaction, it forces it to take more energy to break those bonds than the strong ion dipole interaction that it releases energy. So D is incorrect, because if that was true, delta H would be negative, okay? Now, this is generically speaking. Obviously, ionic is stronger than intermolecular force. The reason why C is going to be right is because that is following what it generally happens. So C works as the correct answer for this one. Okay, looking at a free response question, we've got a graph that shows temperature versus time. A student conducts an experiment to determine the delta H of solution for the dissolution of sodium acetate. The student dissolves 10 grams of sodium acetate in room temperature water in a beaker and measures the temperature over time, and the data is given above. So part A, the student touches the side of the beaker after the dissolution has occurred and observes that it is cold. What experimental evidence is consistent with this student's observation? Okay, that evidence is right here in the graph. So we can talk about how the graph shows temperature decreases during dissolution. That is our experimental evidence for that question. We can see that it dips down in temperature as the dissolution occurs. Now, part B says, is the dissolution of sodium acetate endothermic or exothermic? Justify your answers in terms of the flow of energy. Okay, we should say endothermic. That is the right answer. It's endothermic because the decrease in temperature indicates indicates that energy flows from the beaker to, I should say beaker and water to dissolve the salt, sodium acetate. Because that energy is flowing from the water to the salt, that's an endothermic process. We should probably state that the beaker and water is a surrounding and the salt is the system, to be more, since it is, bring it up right here. So water is surroundings, sodium acetate is the system. Okay, so that shows and explains that because energy is flowing from the surrounding water and beaker is flowing into the salt, which is our system, that's an endothermic process. Endothermic, where heat is being absorbed; exothermic, if it was vice versa, where energy is being released. Okay, last little one. The reaction described above, part E, occurs via two-step mechanism and has a delta H of 0. This goes with the previous questions, but we needed to know that delta H of the reaction is less than 0. So it is a negative delta H. So delta H is negative, which means it is exothermic. So we need to select the graphs that have, I'm jumping ahead. F asks us to identify which of the diagrams could represent the reaction and justify our reaction or our answer choice. Okay, we want to select energy diagrams that show exothermic process. That means energy is being lost throughout the reaction. So on the overall reaction, the product's energy should be lower than the reactants. So that does not work for diagram 1. It does work for diagram 2. It's good for diagram 3 and not diagram 4. So we would say diagram 2 and 3 because a loss of energy is shown during the reaction by having lower energy with the products than the reactants. Okay, by showing there's less energy with the products than the reactants, diagram 2 and 3 work. So something along those lines, being able to word it out in that manner. So this was a long video, but hopefully that was helpful in exothermic, endothermic, and energy diagrams.